Hello, everyone, and welcome to today's workshop. I'm going to open up the chat log on the side here so I can see and make sure that everybody is able to see me. So I'm going to go through a few items here before we jump into the information. First off, I always like to double check, make sure everybody can see me okay, you can hear me okay. There is a chat log off on the right-hand side, so please feel free to go ahead and provide some feedback. Loud and clear. Awesome. Awesome. I was just showing the team here. I have a newer microphone, and so I'm trying to position it and make it so that you can't hear my dog eating his food in the other room. So perfect. Okay. So hello. Hi, Lisa, Ricardo, William, Chelsea. Hello, everyone. Hello. So what we're going to do, we're going to kind of run through what we're going to cover today. Jesse O'Connor. Hi. Hello. So first thing, I just like to let everybody know, I know I've already mentioned it, but the chat log on the side here, please don't hesitate. You are definitely welcome to participate in that throughout the entire presentation. There's also a questions tab. You're welcome to use that throughout the presentation as well. Now, if there are a few questions in there that we think are really beneficial for everybody to kind of pay attention to, we may flag them and hold them at the end and hold a little bit of a Q&A period to go through those. Although if you do post questions throughout, there are some members of our team that may go in and answer your questions right away for you as well. So there's that. The polls tab is also off on the right-hand side. I haven't published any polls yet, but what I am going to do is I'm going to share them with the whole team after the presentation. Just a couple things, and we always appreciate the feedback. Obviously, it just helps us present these a little bit better for everyone. Hello, John, Sam, Sarah, I can see everyone there. So yeah. And I guess one thing I do always like to ask too is where is everybody joining us from? I am in Calgary, Alberta. That's actually where our headquarters is as well, which you'll see in the presentation in a minute. But I'm just always curious where people are joining us from. Boston, Minnesota, Toronto, Texas, Portugal, Vancouver, UK. Awesome. Yeah. People from all over the place. This is perfect. So cool. All right. Well, without further ado, one thing I should warn everybody is sometimes when I share my screen and go to share the presentation, it boots me out of the presentation altogether for a minute. So if I disappear and there's radio silence, I promise I will be back in 30 seconds. Please don't abandon ship. I'll be right back. But we're going to cross our fingers here today and hope that that doesn't happen. I think last time I got away with it not happening. So we are going to see. And DC, hello. Okay, so let me share the screen here, folks. Just give me a quick second. And fingers crossed. There we go. Perfect. I don't think it booted me out, so that's a good sign. So this is obviously just the opening page. We can start with a little bit of an introduction for myself. So my name is Tyler Trapp. I am one of the enrollment advisors here at CircuitStream. I actually come from about 10 plus years of working in hospitality and tourism before this. And I'm kind of I guess, a self-proclaimed artist. No formal training, I guess, aside from little bits here and there, but I've been drawing and painting my whole life. And most recently, I flipped into a little bit more digital art with my iPad. So that's a little bit about me. And then Dustin, this is going to be the instructor running the show here today. He'll be up on the stage in just a minute. But Dustin, he's one of our instructors. He spends a lot of his time either building or playing games with friends. He loves programming and technical art. And then as you can see on the screen here, he's got over 8 years of experience. He also clearly enjoys birds, as you can see in the photo there. And he'll tell you a little bit more about that passion as well if you ask him when he pops up on stage. Okay. So for today, for the actual workshop itself, we are going to go through a few things. Currently, we're in the introduction stage, about 10 to 15 minutes, as it says. As soon as this finishes, we're going to move into the technical session. That's when Dustin's going to come in and boot me out and teach everybody all the bulk of the content. We'll wrap up and do some resources, meaning that I'll pop in after Dustin has finished, and I'll provide you with some links and just some general information about us and our workshops and our courses here. And then, like I said earlier, we'll do a little bit of Q&A at the end to make sure that everybody's questions are answered there. So without further ado, let's just jump into this a little bit here. There we go. So CircuitStream, we were founded in 2015. Our owners, just noticed a big gap in personalized training and education in the XR industry. XR, of course, is just a fancy umbrella term for both augmented and virtual reality. So they obviously started CircuitStream in 2015, and to date, we've supported over 40,000 individual learners, which is amazing. Obviously, it's a massive milestone for us here. Those learners have participated in our workshops like this one or in our courses. We have 6-month courses, 10-week courses, a bunch of different options there. But yeah, obviously a huge milestone for us. The team at CircuitStream is kind of located all over the place. You can see on the map here that our headquarters is in Calgary, Alberta. That's where I'm located. Lou and Mike, the founders, are also located here, and a few of our staff members as well. But then you can see, obviously, we're kind of scattered all over. This is by no means our entire staff body, but just meant to kind of show you some different locations around the world that we are currently located and working from. Unity is really important. We are partnered with Unity. We're what's called a certified training partner with Unity. And in order to be approved as a training partner, you do have to meet very specific criteria. You have to have, highest level of training. You have to have a specific focus on expertise and quality education. So obviously we've met all of those criteria, and we do partner directly with Unity for all of our certification here, which is great. Looks really good once you take the course and it's backed by Unity. CircuitStream, above all else, is an educational company, but you can see here we've had the pleasure of working with many other companies as well. The VR and AR industry is accelerating at an insane speed right now. We probably have pages and pages of logos that we could share, but this one here would just be a good snapshot of some of the top companies that we are currently working with or have worked with around the world. And then Unity, very important. So what is Unity? If you're familiar with this screen here, you've probably played in Unity before. And more specifically, I guess, if you're familiar with the muffin clicker game that we have on the screen right now, you have likely taken our C# course, our 4-week C# course. But for those of you who are completely brand new to Unity, Unity is a development engine. It's a program that can be used to create both 2D and real-time 3D content. We include augmented and virtual reality. Unity is widely considered the top program for beginners. If you're looking at doing XR applications, it's a really good program. It helps and provides a ton of support. Unity's impact. Unity is currently actually used to create over 60% of the world's AR and VR content. I guess that kind of goes a little bit more to back up the previous point that I had made there. And currently, Unity is being downloaded 3 billion times per month, and it's currently existing in 190 countries around the world. So definitely a big company with a ton of impact, like I said. And then how does this work? How does the whole course work, or courses work? How does XR development and design, I guess, in general work? Well, it all starts with an idea. This is just a really quick kind of overall topical snapshot to show you what the process would look like. But it starts with an idea. From there, you're going to build your assets, bring them into Unity, and create immersive interactions using scripting, C# programming language. Once you're happy with your build, then you'd leverage a software development kit to ensure that your target device is compatible with your build. And once you've done that, you can render it, you can publish it, and there you've got the app from initial idea to actual execution, and export it into the device that you're looking at doing it with there. So we do have academic offerings. Obviously, that's the model of our company here. We do provide education for XR. So this is our main 3 courses that I can kind of give an overall view. We've got the XR Development 10-week course. We've got the Interaction Design 10-week course. And we have the Unity Developer Bootcamp. Now, the 10-week development and design courses are both considered completely beginner-friendly, whereas the bootcamp doesn't start off at an overly intricate level, but we would consider it a little bit more of an intermediate level with a little bit of experience in Unity required before you pop into that one. But obviously, if you have any questions about any of them, you're welcome to reach out to any of the members of the team here, and we'd be able to help you. What are we going to learn today in the presentation? We're going to be learning Unity Editor, how to deal with prefabs and new objects, different types of game objects and how to use them in a project, game controls and interactions, and basic simple scripting and physics. So that's kind of the agenda for today. And then I guess without further ado, I'm going to try and stop sharing this screen here and hope that it doesn't boot me out again. Okay, there we go. Perfect. And what I can do here is I can invite Dustin back up on the stage if he's ready to go and hop into the presentation. Perfect.
Hello, everyone.
There we go. All right, well, I'll get out of the way and just invite me back up whenever you're finished there. Thanks, Dustin.
Okay, awesome. I'm going to share my screen, so just 1 second here. Okay. Awesome. So yeah, today we're going to be making a breakout game. And if you've never seen a breakout game before, like I haven't, so I had to look this up and figure out what this was. Basically, it's a game where you have a ball that goes up and down, up and down. It's kind of like Pong, where you kind of hit the ball and make sure you break the blocks in the top. And the goal is to break all the blocks before or without the ball going down under the paddle, which is your player controller, I guess. So we're going to be recreating a version of this, not completely exact, but I'll try my best. So hopefully everybody's ready. I'm going to be doing this basically from zero. So I'm going to be creating new scripts, going to be creating prefabs using all of Unity's assets. I'm not going to be importing anything except for some audio, which I think should be available to you. So I'm going to start by opening up the Unity Hub, and forgive me, I have a lot of applications right now. So this is the Unity Hub. And to answer one of your questions, if you have the Unity Hub installed, you have to first install a version of Unity in order to create a game. So you'll do that here. And then you create a project. So we're going to create a new project, and it's going to be a 2D template. I'm going to call this, sure, Breakout Game. And sure, I'll put in my location, school projects, and I'm just going to hit Create Project. Now, I don't have a chat window open, so I can't really see any questions or anything like that. Maybe if I move this over here on my second screen. Okay, maybe that'll work. Cool. All right, I can still see people typing. Awesome. I need another screen. I need more desk space. And this is going to take a couple seconds. It usually doesn't take this long, but I don't know why. It's taking its time here. So we're going to, as they said, we're going to be doing a 2D game as a template. And I have it open. Here's my sample scene, and I'm just going to go ahead and delete my sample scene or rename it, I guess. Maybe I'll just rename it. Level 1, sure. In my sample scene, I have my main camera. Now we're going to be making a 2D game, and I'm going to add a component to my camera called a pixel perfect camera. And this is going to help me just kind of deal with the pixel art, make sure everything's uniform. So I have an interesting setup here. I have my game view in the middle here, my console on the right, and my project on the left. I'm going to just keep this as free aspect. That's fine. However, right here, I have a reference resolution, and I want to make sure this is something to start with. I'm going to do 160 by 192. That way, it's kind of like a reverse Atari sort of resolution. And then I'm going to check crop frame on X and Y. This way, it will keep my frame always as a 160 by 192. And I'll put the pixel per unit to 4. And I'll also click edit, run in edit mode. That way I can actually see it in my game view, what I'm looking at. So this is going to be what I'm working with here. Actually, you know what? I'm going to do 192 by 160. I'll have it more square. There we go. And that can go away. Okay, so here is my game. I'm just going to center myself by double clicking on the camera here. And I'm going to start by creating a very basic, I'm going to right click in my hierarchy, go to 2D objects, and I'm going to create a sprite. I'm going to create a square sprite. I'll give it a name. I'll call it block. So in this project, I'm going to call the little blocks at the top that are ball hits. I'm going to call those just blocks. And then I'll have the ball, and then I'll have like the player or the paddle at the bottom. So starting off, I have a block, and this is my simple square sprite. I'm going to have this be, let's see, a scale of 3 and 1.5. Yeah, I'm gonna have it as a scale of 3 on the X and 1.5 on the Y. Just this is gonna be my singular block here. Now, before I move on, I want to go to my edit grid in snap settings, and we want to make sure that we set our snap settings to be more in line with what we want. I want to move every 0.5 units. And yeah, I'll keep it like that. So now if I hold down control while I'm moving things, they will snap every 0.5 units. Or they should, hopefully. You just make sure that's right. 0.5, 0.5. Yeah, should be good. Okay. So I'm going to have this as negative 1.5 on the X. Perfect. So it's just right here, a line down the center. Now I'm going to, before I actually copy this and change it and do anything with it, I'm going to turn it into a prefab. Where is the grid snap? Edit in the very bottom, grid and snap settings. In here, you can change how much snap you want on the size, or you can change the size of the grid, and then how much you want to snap when you move, rotate, and scale it. All right, so before I actually duplicate this, I'm going to create a prefab. So in my assets folder, I'm going to right click, go to create folder, and I'm going to create a prefab folder. Prefabs, I'll say. Then I'm going to drag my block into my prefabs folder to turn it into a prefab. We know it's a prefab because it has turned blue. Now that it's a prefab, I can copy it and paste it or duplicate it, whatever I want. And if I want to edit them, all I have to do is edit the prefab from now on. So I'm going to hit Control D on this block to duplicate it. And then while I'm still holding Control, I'm going to grab the X gimbal here and move it around to snap into position. So I want it to be right beside this one, just like that. This is how I'm basically going to build or start building my game. And actually, I'll just start building a line using Control D to duplicate. And I'll just add 1, 2, 3, 4, 5, 6, 7, 8. There we go. And I'll just select all of them by holding Shift. So I select the first one, hold down Shift, select the last one. I'll hit Control D to copy all of them. And then again, I'll just snap them on the other side. There we go. Nice line of blocks. I like to keep my projects organized. So I'm going to actually take these blocks and put them inside a single game object. So I'm going to create an empty game object here. And I'll just call this a row, I guess. I will reset its transform. And then I'll drag all of my blocks onto that. Now, if you want, you could also turn this into a prefab. I don't think it's necessary, but you could absolutely turn this row into a prefab. So you have a row prefab with a bunch of block prefabs inside of it. Now I'm going to duplicate this row and I'm going to move it down, snap it down, duplicate the row again, snap it down, duplicate it again, snap it down, and maybe one more time, I'll snap it down. Okay. So here is all my rows. Now, if I remember correctly, they have different colors. So let me just double check here. Breakout game. Yeah, we've got like red, orange, brown, yellow, green, and blue. Okay. Let me see if I can duplicate this. So I'm going to select all of my blocks in my first row. So holding Shift, I select all of them. And I'm going to find a red color. And then for my next row, I'm going to do the same thing, holding Shift. And I'm going to give him a orange color. My next row, we'll give them a brown color. Brownie. There we go. In this row, I will do yellow. Oh. And then we have green. And the last one is blue. So let me duplicate this row again. And there we go. There is all of our blocks. Again, I like to keep things organized. So I'm going to create another empty child here. I'm going to call this blocks, I guess. reset its transform so it's nice and zeroed out. Then I'll drag all of my rows as a child of that blocks game object. Nice. All right, so I think these are supposed to be at the top, so I'm going to grab the Y axis here and kind of snap them all the way up. Not all the way up, but close to. I think it's like something like there. I'm just estimating right now, so. All right, that's our blocks. Now, we need a player and walls, and we also need a kill zone and a paddle and the ball. So I'm gonna just create another 2D object. I'm gonna create another sprite. I'm gonna do this all with squares. So I'm creating another square here. I'm gonna reset its position to 0. And I guess I'll make this the ball. So I'm gonna have the ball be a scale of 0.5 and 0.5 on the X and Y axis. So it's kind of small, but that's good. I'll call this ball, even though it's square. I'll create another sprite, another square here, and I'll call this a wall, actually. So this is going to be our wall, and I'm going to just zero it out. I'm going to hold down Control and bring it all the way to the right-hand side here. Then I'm going to press R for the scale tool. Then I'm going to scale it up all the way, and so it at least goes outside the bounds of the camera, like that. Then I am going to hit Control D to duplicate this. I will hit W to switch back to the movement tool. And then I will hold down Control and snap it all the way to the left. So I have a second one on the left-hand side here. So we have two walls. Actually, sorry. Before I do that, I'm going to create a prefab out of my wall. Since I'm going to have multiple walls, I'm going to make it a prefab. That way, if I have to edit the walls, I only have to edit the prefab. So I'm going to drag my wall into my prefabs folder to create a prefab of it. Now I will duplicate it and drag it over. Now I'm going to duplicate it one more time. I'll reset its X position to 0, and I will hit E for the rotation tool inside the scene window. Then I'm going to hold down Control again to have that nice snapping feature, and I'm going to click on this blue circle and drag it 90 degrees so I have a nice flat top. I will hit R for the scale tool, and I will scale it up so it meets each wall. And then I'll hit W for the movement tool, and I will hold down Control and scale it all the way to the top of the window. There we go. There's 3 walls, and one more time, I'm going to duplicate this top one, and I will drag it all the way to the bottom. I have a nice box that this ball can bounce around in. Now, the box isn't rendering, like the box is outside of the camera's render zone. So I'm going to remove the sprite render. It's not necessary. I don't have to actually see the sprite itself, but I'm going to open the wall prefab, and I'm going to remove the sprite render on the prefab. And then I'm going to add a physics 2D. I'm going to add a box collider 2D. So they all have a box collider now. Now I'm going to exit my prefab editing. And if I select these walls, you can see they no longer have the sprite render, but they do have the box collider. So the ball will still collide with these boxes, even though we can't see them. The ball itself needs a physics 2D box collider as well, so it can collide with things. So I'm going to add one to the ball itself. And same with the blocks. All of my blocks require a box collider, so I'm going to add again a physics 2D box collider to all my blocks. I'm going to create an empty game object just to hold my walls as well. Keep things nice and clean. And name it walls, reset its transform position to 0. Holding shift, I'll select all my walls and just drag them as a child of my walls game objects, and then collapse that. Nice. We need a paddle. We need something that we can actually control. So I'm going to, again, right-click. I'm going to create a 2D sprite, another square, and this time I'm going to name it call player. I'll reset its position. This is going to be down here. Say right there. Sure. Let's give it a size. Let's do 3, 5, yeah, 5 or 6. Sure, whatever. And I will make its y scale 0.5. So it's more of a paddle shape there. Maybe I'll make it a little gray. I don't know. All right. There's my player. It again is going to need a physics 2D box collider. Okay. So far we have our actual game. We can actually see our game. We have all of the different colors, and we have a ball and a player, and we have our walls so the ball can bounce around. But now we have to look at physics, and we have to look at a little bit of coding in order to make certain physics happen. So starting off, I'm going to make sure that my ball has a rigid body 2D. So I'm going to add another component onto my ball, physics 2D. And where is it? I know it's here somewhere. I'm just going to search for it. Rigid body 2D. There we go. And this rigid body is basically going to allow our ball to collide with things. It will actually have physics events and move around, have velocity, etc. Now, I don't need gravity. This is going to be completely dependent on bouncing. It's not going to have any gravity, so I'm going to set the gravity scale to 0. And that's good for now. I'm going to open up the constraints, and I'll set the rotation constraint to be frozen. That way it will not rotate at all, and the ball doesn't need to rotate. And the body type is dynamics, which means it'll just collide with things. The player is also going to need a rigid body. So basically, anything that moves around should have a rigid body. Anything that moves around. So that would be just the ball and the player. The blocks don't move. They just get destroyed. The walls don't move. So just these two need a rigid body. So I'm going to add another rigid body to my player. However, with this one, I'm going to set its body type to kinematic. Yeah, I'm going to set it to kinematic. I don't want it to collide with anything. The ball will collide with it, but it doesn't collide with anything else. I will also freeze the rotation on the player, and I will freeze the Y position. We don't want it to go up or down. We only want it to move left and right. All right. Now, if I hit play, nothing will happen. Currently, we have all this physics, but we don't have gravity, so the ball's not going to fall. So we actually have to use code to make physics happen here. We have to add velocity to that ball. So we're going to have to do some scripting, and I'm not handing out scripts for this, what do you call it, presentation, I guess. So we're actually going to make our scripts ourselves from scratch. So I'm going to go to Assets. I'm going to create a new folder, and I'm going to name it Scripts. I like to keep everything nice and organized, so make a scripts folder. And while I'm at it, I'm going to import my sounds pack. So I'm going to bring the sounds pack into my project as well. So I'm importing my free sounds. I have 4 of them that I picked out here for the game. Import those. There we go. I'll do those later. All right, for now, we're going to create a script. So in my scripts folder, I'm going to go right-click, create C# script. And I will just name this character controller. Player controller? It's whatever you want to call it. Player controller, I guess, not a character. Player controller. There we go. Okay, here is my player controller. Now I don't need the start method. So all we're going to use is the update method for this player controller. And update is called every frame. So if I have a frame rate of 600, it's going to be called 600 times a second. So what we want to do is we want to move this, this player towards our mouse's position every update, right? Every update, we're going to move it towards the mouse's position. Now, there's multiple ways you could do this. I'm going to show one way that won't work, and then I'll try to show a better way that'll work better later on, but we'll do the simple way first. So basically, we're creating a script. For those that don't know, we're creating a script so that we can attach it to a game object as a component. So I'm going to attach this player controller script to my player game object to create a component in here. And now that I've turned this script into a component, this component is going to have stuff like the update event. And then we can do logic like moving the player towards our mouse position. So let's get started on that. Here we go. So in order to move the player, we have to get the mouse's position. So to do that, I'm going to use input.mousePosition. Now, in order for me to actually use this mouse position, I have to convert it, because if I mouse over this, I see that it's the current mouse position in pixel coordinates. That's screen coordinates. We don't want it to be in screen coordinates. We want it to be in world space coordinates. That's the X, Y positions inside world space. So to do that, we have to get the camera. So first, I'm just going to create simple variables for this. So I'm going to say vector2. That's the type of data we're creating, a vector2. And I'm going to give a name. I'm going to say mouse position equal to the input.mousePosition. Next, I have to get the camera. So I'm going to get the camera. I can just type camera.main. I'm just going to do this as simple as possible. And what we want to do on the camera is we want to call a method called screen2world_point. It will convert these pixel coordinates to a world coordinates. So that's what we're going to do. It's a method, so we have to pass it the mouse position. So we do that in parentheses, and then we pass mouse position. So whatever this value is going to be set into this variable, and then we're sending this variable's data to this method, and it's going to convert it from the screen point to a world point. Now, this is a return type method. We can see when we mouse over it, it has a vector3 return type. So whenever we get return types of values, we have to basically grab those return types. We have to get them somehow. So I'm going to create a variable to hold that return type of a vector2. I'm going to call this a vector2 variable with a name, I'll say world mouse position. Say it's equal to this. So now we have our world space mouse position. All right, so we have this position of where my mouse is inside my game. Now we need to basically make it so my player paddle, it moves towards my mouse position, but we don't want it to move all the way. Like if I don't want my, if I have my mouse way up here, I don't want my paddle to be way up here. I only want its X position to be aligned, not the Y position. So to do this, I'm going to not close Unity. Jeez. Way too many projects. There we go. Okay, to do this, all I'm going to do is I'm going to set this world space mouse position. I'm going to set its Y value equal to our transform's current Y value, so position.y. The transform.position.y, if you remember transform.position.y, this is actually transform position Y. So it's going to be -15. So every single time I update, I'm setting this position, this Y position to -15, so the Y never moves. And then we have the X position where the mouse is, the Y position's down here. So now all I have to do now is say, okay, transform.position is equal to world mouse position. Setting the position of the transform to the current world mouse position with the Y static, I guess. I'm going to save this and flip back to Unity. And now that we have code that will actually do this logic, remember we have to attach the script to our game object in order for it to work. So I'm going to attach this player controller to my player game object. Now we can just test this to make sure it works. hit play. And there we go. I got this paddle. We can move it back and forth with my mouse. Doesn't matter where I move my mouse, it'll always kind of be aligned with it. Okay. Next, let's focus on the ball. So the ball, I'm going to, again, have to create a script for this. So I'm just going to create a new C# script, and I'm going to call this a ball. Sure, we'll call it ball. Okay, seeing how I'm doing on time. That was 2:30, right? Okay, so here is my ball script. Now, with my ball script, I am going to have to get a hold of the rigid body component. So if I actually look at my ball here, this rigid body component, this is how we give it velocity. This is how we give it physics. So I have to change the velocity of this ball in order to make it move in a direction. So to get this rigid body, I'm going to create a variable to hold the rigid body. I have a fetish with closing Visual Studio. There we go. So at the top, I'm going to create a variable inside my class. And this is going to be a variable that will basically hold data as long as this ball exists. And it's going to be a data type of rigid body, or the 2D variant to be precise. I'll give it a name underscore RB. Names don't really matter. It's just how you describe the variable. It's how you also access the variable. And following proper Microsoft coding conventions, I'll put private at the start just to specify it's private. I got that right. Okay. Now, when the game starts, we want to access our rigid body and we want to change its velocity. So I'm going to have to actually get a hold of that rigid body's velocity value. So if I put my variable RB in here, I hit period for dot notation, I can see all of the properties and methods inside of this rigid body 2D component. And the one I'm looking for is velocity. This is how I can change the rigid body's velocity. However, what am I changing it to? I have to set it equal to something, right? But what am I actually going to set it to? Well, we want the ball to either go to the top left or top right when the game starts, or anywhere in between those two values. I don't want the ball to go down, I guess, when the game starts, because that might like psych out the player, I guess. So we'll have it go like to the top left or top right to start off. So what I'm going to do is we're going to use vector 2 directions. So directions with vector 2s are a value on the x and y axis where they basically equal a value between, or they equal 1. That's how we kind of specify it. So if I was to say x 0.5 and y 0.5, that would be 0.5 on the x, 0.5 on the y. So you're actually going to be pointing top right. Where if I said x negative 0.5 and y 0.5, that would be top left. But we want a value between these two. So what I'm going to do is I'm going to create a vector 2, and I'm going to call this start velocity. Now, I don't want the game, okay, I don't want the ball to go straight up and down. So maybe I will just give it a yes or no direction, top left or top right, and that's it. So what I'll do is I'll say, okay, I'm going to use a random range in order to get a random number. So random.range, or random.value, sorry. You can see here that this returns a random float, which is just a decimal point number, between 0 and 1. So if I want a 50% chance for something to happen, I'm going to have to check if this random value is greater than or less than 0.5, basically. So I'm going to do an if statement. If this random value is greater than 0.5, add an F on the end to specify that this is a float. And I'm going to set the start velocity equal to a new vector 2 that is 0.5 on the x and 0.5 on the y. Then else, if it's not greater than 0.5, I will set the start velocity equal to a new vector 2 that is negative 0.5 on the x and 0.5 on the y. So either I'm going to use some comments here just to simplify this. Top right or top left. This is our simple if statement to get the velocity that we want. And last, I'm just going to set the velocity to my start velocity. Okay, now let's test this. Save and flip back to Unity. Thank you. And I'm going to click on my ball. And I have to make sure I attach my ball script to my ball in order for this to work. So I'm going to attach it on there. And well, here's one issue that we're going to run into. My ball needs to know this rigid body. It doesn't know how to get the rigid body automatically. We actually have to tell it to get this rigid body. Remember this variable? I don't know why I can't just flip back and forth there. Remember this variable we created, this rigid body variable. We actually have to tell it to get this. So one thing we can do is we could serialize it. And just like all these other values inside Unity, like this rigid body here, it has mass, linear drag, angular drag. These are all serialized values. That means we can change them. We want to do the same thing. We want to have a value that we can change inside our ball script. So to do that, we're going to add an attribute called serialize field. And this will allow us to see our rigid body inside this ball script. So now I can drag my rigid body in there and tell it where it is, basically. So if I test this, we can see it's going up at a speed of 0.5, 0.5, which is quite slow. So we may want to increase the speed a little bit here. So I'm going to add another value here. Private float. I'm going to call this move speed. And I'll give it a default value of 30. Yeah, let's do 30. We'll see. Again, I'm going to serialize this so I can change it in the inspector window. Then I'm going to multiply my start velocity by my movement speed to increase this direction by a number, basically. You got to think of the start velocity as a direction right now. It's either top left or top right. But when you multiply it by a single number, it increases that direction. So it'll increase the speed. All right, let's see if this works. Okay, it's a little fast. We can see it's just sliding to the right. So we're not actually getting the correct behavior we want. And what we're actually seeing is the ball shot up and it hit the wall and then it slid to the side. So the ball isn't bouncing. This is physics materials. So we need to create a physics material that is going to allow this ball to actually bounce against a wall. So I'm going to create a new folder inside my project window. And I'm going to call it materials. In my materials folder, I'm going to right click, go to create, and I'm going to create a 2D physics material 2D. So I'm going to create that physics material. And I'm going to call this bouncy material. Bouncy, C material. There we go. This material has two values, friction and bounciness. I don't want any friction, and I want bounciness to be 1. So what bounciness basically means is when this ball collides with a wall. Bounciness is, think of it as a value between 0 and 1 of how much of its velocity is going to get reflected off that wall. If I put the bounciness at 0.5, that means when the ball hits the wall, it's going to bounce off of it at half the velocity. So it'll go like, I guess, half the speed afterwards. So 1 means the speed will not change at all. Now I need to actually apply this bouncy it still says boundy. That's triggering me. I don't bound. Okay, whatever. Anyways, I need to apply this boundy material to my colliders. So I would have to go to all my colliders and apply this material inside the box collider slot here. But since I pretty much want every single collider in this game to be bouncy, another way I can do this is I can go to Edit, Project Settings, and in here I have Physics 2D, and here we have the default material. So I can actually make my bouncy material my default material for everything. It still says boundy. I don't, whatever. So now let's see if it makes any difference. Look at that. It's actually bouncing around now.
Can everybody see me or hear me right now? I'm not hearing Dustin, and I just wanted to see if it was just me or. Okay. You can't see me. Well, I can pop back up on camera here. I don't mind at all. Hello. If oh, it looks like Dustin lost his internet connection, everyone. So he will be right back. It says that you still can't see me. I'm sorry, folks, for the technical difficulties here. You must have just lost an internet connection on Dustin's side there. You can see me. Perfect. Yeah, sorry, everyone, about the technical difficulties. This is a very rare occurrence for us. Dustin must have just lost his signal, so he should be right back.
Hello.
There we go. Perfect. Yeah, just a lost signal.
My USB drivers just completely crashed on me.
Oh, no. No. Well, it looks like, yeah, everyone's still here. We're good to go. Are you able to hop right back into it, Dustin, or do you need a minute there?
Yeah, I can hop back in. I'm gonna have to load up my project, and I might cheat a little bit here, just to kind of catch up.
Sure. And I can.
Yeah, I hit play, and the game just froze. Everything disconnected. That was crazy.
Technology sometimes, right?
All right.
Timing was perfect. You hit play and got killed by your own game, it says. Just another day in the developer life. Yeah, stay on.
Oh, man. I've done how many classes, and this has never happened. They would figure it happened on a live stream, right?
Hey, for me, it normally boots me out when I try and share the presentation. I don't know why my system hates me sometimes, but I guess you took it this time instead.
Unfortunate. And because my USB drivers completely crashed, I had no access to my keyboard, my mouse, nothing. So guess what happened to my scene? It was
Murphy's.
not saved.
I see that Murphy's law there,
Yeah.
Dayon.
All right. I'm ready to jump back in.
Okay, you'll be able to pick back up from there, hey?
I'll be able to I'll be able to do it pretty quickly here. No
Okay.
worries.
And if we run over the Q&A a little bit at the end, that's okay. But I'll get out of the way here.
Okay. Oh man. All right. This is going to be a little messy. I have everything just off my screen now. I have nothing up. So here we are. Back to level 1. Literally, I have the scene's completely new. I never saved it, so I'm gonna quickly blast through and re-add everything I can remember to add. 190, 160. 160. There we go. And 192. I had 4 pixels per unit here. Turn that on. Crop everything. And luckily I made those prefabs, so I'm gonna bring my row in, and my size may be a little off, perhaps. Oh, right. It's I think 192 and 160. There we go. I'm gonna copy these and move them up. I apologize, everyone. This sucks. I'll color code them later. I don't think the color matters, so we'll just have white rows for now. Here's some rows. Okay. Put those up there. And now I will create a ball that is 0.5 and 0.5, 0, 0. Make it a little gray, I guess. I don't know. I'm going to add my box collider to it. A rigid body. And no gravity. Dynamic, good. Freeze rotation. All right. Move the ball a little bit down. I do my player next. I think it was like 6 and 0.5, maybe 5 and 0.5, whatever. There we go. Another rigid body, kinematic. Again, freeze those two. Add my box collider. My scripts, I'm going to attach my player controller to my player and my ball to my ball. Reattach my rigid body. Maybe I'll put the movement speed to like 20. I don't know. Might change that later. Okay, what am I missing? Walls. I'm going to put my walls in here so we can see this wall. 1, 2, 3, 4. There we go. All right. Let this be a lesson. Save your scene regularly. The kill zone, the bottom one here. All right, let's see if this actually works still. Hopefully I didn't forget anything. Oh, the bouncy material didn't save. Okay, so I'll have to re-add that. Nope, it did not. Okay. All right. Why is it not working? I did add it. Physics 2D, bouncy. Oh, did this not save to? 0 and 1 bounciness. There we go. Okay. Save project. Save the scene. All right. There we go. Now look at this. So we can hit the ball and it can bounce up and down, and Great, we're getting some actual gameplay here. All right, let me reopen my script. So next we want to make it so that the blocks actually get destroyed when we hit them. Now, we want to have collision events. So when I collide with something, I want an event to happen. I want to know what I'm hitting, because I want to do different things depending on what I'm hitting. Am I hitting the blocks on the top? Am I hitting my walls? Am I hitting my player? Am I hitting my kill zone? What am I doing? So I'm going to do collision events in scripting, and I'm going to do layers to tell what I'm hitting. So I'm going to need a layer for each thing that I'm hitting. So we have layers, or sorry, tags, I mean, is what I'm going to use. And they're in the top here. I can add tags. So I just clicked on a game object, and it doesn't matter what game object you click on. And there's this tag thing inside the inspector window. And most things are untagged by default, except for like the main camera. But I'm going to create some tags. So I went to add tags, and then we see that the list is empty here. So notice there is some default tags here: respawn, finish, editor only, main camera, player, and game controller. I'm going to use the player for the paddle since it's already defined. Why not? So I'll make this player a player tag. And then I will make the kill zone a respawn tag. So there's two of them. Next is the walls. So the walls, I'm not going to change all of them individually. Again, I'm just going to change the prefab. So that way, when I change the prefab, it will change all of the walls themselves. So I'm going to click on the prefab, and I'm going to go set its tag. Now, I don't have a tag here I want to use, so I'm going to create a new tag, and I'm going to hit the plus, and I'm going to call this wall. Now I can set the tag as the wall. And it should not have changed the kill zone. Okay, good. What's next? The player has one. Oh, the blocks. Yes, the blocks need a tag as well. So I'm going to create another tag for the blocks, and I'm going to call this block. I'm going to set the tag of the block as block. There we go. So all of my individual game objects or types of game objects have a tag of some sort. So now if I go to my scripts folder, scripts, and I'm going to open my ball script back up. There we go. All right. Here is my ball script. Now, I want to know, I'm going to delete this update method. I do not need that. I want to know when I am colliding with something. So to do this, we're going to use a method that Unity has that is going to call for us called on collision enter 2D. That's the 2D variant. We're going to create this method inside our class scope. And what I'm going to need for this method is a couple things. I'm going to need the collider. So I'm going to get the collider off of the collisions. You can see here that when I call this method, or when Unity calls this method rather, they're going to give us this collision 2D variable. And this collision 2D variable has some data inside that I can use. If I type in collision and hit dot, we can see all the data I have access to. We have collider, and we also have other collider. So I want the other collider. So I'm going to say, I'm going to create a variable to hold this. Say collider, other collider is equal to collision dot other collider. Pretty sure it's the other collider. Pretty sure, yeah, okay. Oh, collider 2D. There's a difference between 3D and 2D, so you have to specify 2D sometimes when we're working with 2D. Now that I have access to the other collider, so for example, when my ball is bouncing around the screen, when it collides with the block, my ball's collider is going to collide with the other collider. So that's what I'm getting is the block collider, or whatever I'm colliding with. Now that I have access to the other collider, I have access to the game object that collider is attached to. So if the collider is attached to a game object that is tagged as block, I can figure that out inside my code here. So I can create another if statement, and I'm going to say, all right, if other collider dot compare tag, or comparing tag. So I want to see if the other collider's tag is equal to, and we're not doing the equals, we're just doing a method that returns a true or false value. And here we'd say, well, if it's a block, if the tag is a block. So I'm creating a string data here to compare if the other collider's tag is block. So if it is a block, let's just destroy it. So I'm going to use destroy other collider dot game object. Test this out real quick, make sure it works. I have anxiety now. I'm afraid to press the play button. Okay, it doesn't look like it is working. So I need to make sure that my blocks are saying block. Yes, they are saying block. So I wonder if the other collider is not actually the right collider, which would be weird, but whatever. So yeah, it is called block. We can see the tag of these are block. And I am going to confirm that. So let's just try collider. Maybe it's just collider, not the other collider. Well, that would destroy the game object. There we go. So now we're actually destroying the blocks when we collide with them. Okay. And this is the basics of the game. However, we can continue to add more and more and more and more and more onto this. So let's keep going. Let's do some sounds. Sounds make things nice and fun. Actually, hold on a second. Let me just reshare the screen and I'll say share system audio so you can actually hear it. There we go. Also, notice my game window isn't showing stuff correctly. That's because I don't have run in edit mode checked on my Pixel camera. So as soon as I click that, it kind of shows it in edit mode. Now, I have 4 sounds here. One for dying, one for getting hit by a block, one for hitting a player, and one for hitting a wall. So I'm going to make it so when I collide with things, it's going to play these 4 separate sounds. To do this, I'm going to have it all done by the ball. Now, in order to do this, I need to use a component called an audio source. So I have an audio source on the ball component, and I'm going to have it not play on awake. I don't want it to loop or do any of that stuff. I want to make sure it is 2D, good, awesome. Okay. So I have an audio source. Now what I'm going to do is I'm going to tell this audio source to play different sounds. So I need to first have a reference to all 4 of these sounds, and then I can make them play depending on some logic. So let me go back to my code. So the same way we were able to get the rigid body, we can get the audio clips. So I'm going to create another serialized field variable, and it's going to be a audio clip, type of audio clip. I'll say private just to be clean. And I'm going to have 4 audio clips. Now I could sit here and type this all out 4 times, but I'm going to be lazy, and I'm going to go to a new line here, and I'm going to define them all at once. So I'm going to say, okay, I have the death clip, and then comma, and I have the other ones. Do I have? I have the wall clip, the player clip, and the block clip. So those are my 4 audio clips. I just defined 4 separate variables with one initializer, I guess. Now, in our collision 2D, we check if we're hitting the block, we're destroying the block. This is also where I can play an audio clip. So I need a reference to my audio source in order to play one of these clips. I have to actually tell my audio source to play an audio clip. So what I'm going to do is, again, I'm going to create a serialized field for the audio source. I'm going to call it underscore audio source. I guess I could have called this underscore rigid body and quit being lazy. All right, in my block, I'm going to say audio source dot play one shot. Then I'm going to pass in the clip. So this is how I'm going to play an audio source, and then I just have to pass the clip inside these parentheses. So I'm going to pass it. Well, if I'm hitting a block, I'm going to play the block clip. And we're basically going to duplicate this logic for all 4 of them. So I'm going to copy all of this. And the next one I'm going to do is, okay, if I'm hitting a player, take out that destroy, I'm going to play the player clip. Let me change this to else if. That way only this or this can happen, not both of them. Else if, copy again, I'm hitting a wall, play the wall clip. Else if I'm hitting a, what's the last one? Oh, kill zone, right. Respawn. If I'm hitting the respawn tag, then play the death clip. And that is that. I wish there was a place I could share this with everybody. I know I'm going a bit too fast. I'm going definitely too fast for people to follow along in the code. So I do apologize for that. It sucks that we're a little bit behind, but in my ball, I now have a death clip, a wall clip, a player clip, a block clip, and my audio source. So I'm going to pass my audio source into the audio source section. I have to pass my rigid body into the rigid body section because I renamed it. And then I have to pass my death clip into the death clip one, my wall into the wall one, and my player into the player one, my block into the block one. Now let's see if this works. It might kill my ears. Hopefully people can hear that. All right. I died and it made a doo-doo sound. All right. I know, I'm terrible with sounds. This is why I'm not an audio engineer. So, but that's how you make audio play. What else can I do? Let's make it so our speed. So in the original Breakout game, the ball is supposed to move faster as you hit more blocks at once. So let's make it so the speed of this ball actually increases as we kill blocks. So I'm going to have to do this again with code. So currently we just have a set velocity and we're not doing anything with that velocity. So if we want to make the speed increase, we're going to have to set the velocity every time I bounce against something. Now it's important to note that on collision enter 2D is going to be called after the collision. So when this method gets called, the velocity of the ball is already going to be in the bouncing stage. It's already going to be like moving in the opposite direction, reflected, I guess. So what we need to do is we need to set the velocity every single time it bounces and increase that velocity or increase the speed every time we hit a wall or a block, sorry. So I'm going to need a couple of variables here to help me control. Currently we have movement speed, but I'm going to want I'm going to need 2 more of these. I'm going to need one variable that has a max move speed so I can make it so it doesn't go up infinitely. And I need to have another variable that is move speed increase per block. That's how much it's going to increase per block we hit. So I'll have this at 2. Let's do this at 50 and yeah. Okay. Awesome. So this is going to be my increments. So every single time I hit a block, I want to increase my move speed. So I would right here, I'm going to say, okay, move speed is plus equal, so that's increasing it, addition by my move speed increase per block. So I'm going to increase it by this. Now, remember, I want to clamp this. So I'm going to actually have to change this a little bit. I want to make sure that this move speed never goes above 50. So I'm actually going to say, okay, we're going to set the move speed equal to math f dot clamp. I don't have to use clamp for this. I could use min. So if I say min, it's going to take the smallest value. So the smallest value is either going to be the move speed or the move speed plus the move speed per block, or the maximum move speed, if that makes any sense. So we're setting the current movement speed equal to whatever's smaller, the move speed plus my movement speed per block, or the maximum movement speed. It's kind of just clamping the max, I guess. However, setting my movement speed isn't going to actually increase my velocity, right? We only set our velocity equal to the start velocity multiplied by the movement speed here. So we never actually we never set this again. We only set it in the very beginning. So if we want to actually increase the speed, we have to call this, basically do this again. Now, the issue here is that, well, we need a current velocity, not a start velocity. So we're going to have to do something a little bit different. So I'm actually going to copy this line. At the very end of this on collision enter, I'm going to paste it. So we want to set the rigid body dot velocity equal to the current rigid body dot velocity dot normalized. Normalized. So normalizing basically means that you're taking a magnitude and making it have a value between 0 and 1. So this is changing it from a speed, like a actual movement speed, to a movement direction. It's just a pointing in a direction. It's a value between 0 and 1, which means it can be scaled evenly along each axis, the x and y. So that's why we can multiply by movement speed again to increase the movement speed. So let's try this out. Oh, wait, did I? Ah. Okay. Well. I can't actually tell if it's getting faster or not. Maybe. There's one way to tell. Let's increase how much it gets per... Oh, it's 30. Oh, okay. Right, so the movement speed's 20 by default. Let's make it 50 max, and let's say it goes up by 5 per block I kill. So let's see if this actually works. Okay, that looks like it's working. Yeah, okay, yeah, it's definitely working. There we go. All right, that's cool. I'm gonna put the movement speed increase per block to 2, so it just kind of it's a little smoother, I guess, going up. I'm gonna save my work before this decides to crash on me again. Awesome. Next, let's make it so the paddle. Okay, so the paddle I'm controlling right now, it has no impact on the direction of this ball. The ball's always going in the same kind of angular direction. It'd be nice if we could actually make it kind of change in directions and go back and forth and whatnot. Unfortunately, to do this, we have to make some changes to the code, which it's a little bit more complicated. So starting with the player controller. Currently, we are just setting the transform position equal to the world mouse position. So we're setting the position, the X position of this paddle to my current mouse's X position. However, when you set the position of a transform, it doesn't take into account movement. It doesn't take into account physics. There's no velocity involved. I'm not actually moving my thing over there. I'm just snapping its rotation or its position to that position. So there's no physics involved. So in order to actually do this, we're going to have to add some sort of rigid body velocity in order to actually move the thing back and forth. Now, this is going to be a little bit more complicated. So what I'm going to have to do here is I'm going to have to get a reference to my rigid body on my player. So I'm going to create a reference to the rigid body. 2D rigid body. Okay. Currently, I'm going to comment this out. We're not going to use that anymore. currently we have this world mouse position. Now, what I want, let me just make this a little bit more simple. I can have my world mouse position and I can have my current mouse position. So vector2 current position is equal to transform dot position. So this is my, actually let's do rigid body dot position. So we have the current position of my player, and then we have the position we want it to move to. These two different things, the position we have it exactly right now and the position we want it to go to, where my mouse is. So we need a direction here. We need to know which way is this paddle supposed to move. To do this, to get a direction using vectors, it's always the target minus the source. So if I want the direction to the mouse target, I'm going to say direction is equal to the world mouse position minus the source, which is my current position. So that is a direction. However, this is a unscaled direction, which means that it's actually going to be like if you were to draw a line from my current paddle to the mouse, that's going to be the direction. If I was to normalize this, it would be an actual direction. Right now, it's more like a magnitude. But that's okay. I'm fine with that. I'm fine with the paddle moving faster the farther away my mouse is. So now that we have a direction, we can actually set the rigid body dot velocity equal to the direction. And this will move it in the direction of our mouse. However, we probably don't want it to go like super slow. We probably want to be able to increase this. So two things I'm going to do here. One, I'm going to multiply this by time dot delta time to make sure that my paddle's movement speed scales with time and not frame rate. Second, I'm going to have to scale this somehow. So I'm going to need a movement speed again variable to scale this. So I'm going to create one in the top here. Private float move speed. And I'll give it a default value of, I think I tested this earlier and 900 was good. So I use 900. There we go. So it should move in the direction towards my mouse at this speed, scaled by time. I'm going to save that, flip back to Unity, and I have to pass my rigid body in here in order to tell it where my rigid body is. So now if I hit play, we should see here, it's kind of moving towards my paddle, right? It's not exactly perfect. Now, it's still not taking into account physics calculations, and that's okay. So let me go back to code. I have to turn that volume down. That's destroying my ears. I don't know if it's destroying anybody else's ears, but I do apologize. I'm actually just going to turn the volume to 0 for now. We know it exists. We know it works. All right. So we have the velocity now. I might increase this from 900 to a larger value. We'll see. But now we actually need to apply the player's velocity to the ball's velocity when the ball hits it. So in our player here, we can actually get that rigid body. So I'm going to say, okay, other collider dot get component rigid body. Getting the player's rigid body. This is how we get components attached to components or attached to game objects. So I have a collider component, and then I'm using get component to get a rigid body that is attached to the same game object as the collider. So this is where I can get my velocity. I'm able to access the player's velocity. Now, what I want to do, actually, is I want to add my current rigid body velocity and add the player's velocity. So it'll kind of just add in the player's current velocity is. All right. And rigid body 2D, sorry. Remember, that's 2D. So long since I've worked with 2D. So this will kind of work. We'll still have some issues, but it'll kind of work. So if I like that. See, it's kind of, it hit it. I hit it at a weird angle, and it kind of got a little flattened, kind of. So, but we don't want it to kind of go back and forth like this. So we're gonna have to do we're gonna have to do a couple things here. One is I don't want to hit this ball and have it go like completely back and forth and back and forth. So that's one issue, is we want to make sure that this ball is always kind of going at a slight angle. We want to limit that. We don't want it to do this. This is boring. I don't want to play this. This would make me pull my hair out. Little I have. So what I'm going to do is I'm going to have to limit its rotation, or its like velocity. I'm going to have to limit its velocity. And to do this, I'm going to do something a little weird, I guess. If I can remember how to do this properly. Okay, so here's where I set my velocity. But before I do that, I'm going to get my velocity. So vector 2 current velocity is equal to rigid body dot velocity. Perfect. And now I'm going to make sure that I am doing this properly. Don't want to waste time right now. So here's my example I had from earlier. I'm going to make sure I'm doing this right. Right, clamped angle axis. So, okay, axis, clamp with the angle axis. All right, so I have my current velocity, and it's going pretty fast, so I want to normalize it. I'm going to normalize this to turn it into not a velocity, but a direction. So now it's kind of a direction where this ball is moving. Now we want to limit this direction based on the axes. So I'm just going to limit the x and y depending on the current direction it's heading. This is a bit confusing. There's probably a better way to do this, honestly. I'm just not exactly the most bright when it comes to vector math, so but that's okay. So we need a x and y value. So I want to set the current velocity dot x, and then I want to clamp it. What I'm going to do for this is I'm going to create a new method. As you saw, I had a private float, return type of a float, and this is a clamp assigned axis pretty much, and we're giving a float. Okay, so we're creating a method that returns a float, takes a float, and then returns a float. It's basically going to clamp this float between two values. So I want to clamp it depending on the direction it's heading. So if, say, for example, I passed this my x, so I'm going to say, okay, is equal to clamp signed angle velocity dot x, passing it my x. What I'm going to do is I'm going to check, is my x value, let's say, greater than 0? If my x value is greater than 0, then I am going to clamp it. Axis is equal to mathf dot clamp between, I want to clamp the axis value between a min and a max. Now I'm pretty sure, what was that number I had? It was 0.25. So I want to clamp it between 0.25 and 1 minus 0.25. I did have this as a constant before. That way I could change it without having to change it on here. So maybe I'll do that again. I'll create a constant float max angle, I guess. I will use that instead of hard coding those values. So if you're thinking of an x-axis in terms of movement, in terms of direction, sorry, you have a value of 0 where you're not moving to the right at all, and a value of 1 where you're moving all the way to the right. So that's the kind of value between 0 and 1. How much are you moving to the right? Now, what we're doing here is we have an x and a y. So remember how 0.5 is top right. So what I'm going to do is I'm going to make sure that my x value is never larger or smaller or larger than 0.25, like it's not going to go smaller than 0.25, and it's never going to go above 0.27. That way, it's always kind of in this diagonal sort of direction. It's never going to go just back and forth and back and forth and back and forth, which is quite boring. Now do the same thing for the other side, the else. I'm just going to copy this. This one's a little different because we're checking if it's negative, if the axis is negative, if it's going to the left instead of to the right. In this case, it's a negative angle. We're clamping between the negative angle and the -1 plus the max angle. Confirm my work here. Oh, backwards, right, yes. We check the smaller version and then the bigger version. Clamping does not go negative, so. Right. We're going to check if it's between negative 0.75 and negative 0.25. And then at the very end, we're just going to return whatever the axis is. We can do this for the X and the Y, just to clamp them both. And then at the very end here, instead of saying rigid body.velocity.normalized, I just pass in my current velocity. So I set my velocity equal to my current velocity multiplied by the movement speed. So now it should be completely clamped. And let's test this out. If I can hit it. Jeez. There we go. Look at that. I can actually change the direction of it now when I hit this ball until I suck. All right. Kind of reaching the end of the class here, so I'm gonna hurry up and do these last few things. When it hits the respawn, we want to respawn the ball. So what we're going to do in this case is we are going to set the ball's position back to the center. So I'm going to set the transform.position equal to, what's its current position? Okay, it's not 0. 0 would be like right there. Okay, so I'll just say -6 is a good, yeah, sure. -6 on the Y, why not? Oops. I'll reset the position equal to 0 on the X, -6 on the Y, and 0 on the Z. And then when I reset the position, I also want to give it a start velocity again. So I'll just call the start method instead of having to retype all that out. So I'll also say start, and that will set the initial velocity. So if I die now, it should actually pop up on the top again, just like that. Cool. Now I'm going to add some UI real quick. So I'm going to go to UI, and I'm going to create a canvas. And how am I doing on time there? Am I okay to keep going after 2:30? So I created a canvas, and yeah, I'm good. Okay. All right. So I created a canvas, and this canvas is basically responsible for drawing all our UI elements. Everything we draw, images and whatnot can go on a canvas, and it's just going to be drawn straight to the screen. So on this canvas, I'm going to use something called Text Mesh Pro to display text elements. Now, when I right-click and go to UI, I can click on Text Mesh Pro and create a text element. It's going to ask me to import TMP Essentials. So you have to click that. I'm going to import this, and it will import all the TMP stuff that I require. I don't know why it opens Visual Studio. And that's it. That's all I need. So you can see here, I now have new text. If I double click on this canvas, it'll actually focus on it inside my inspector or inside my scene view. This is where I can clamp it places. Now, again, I'm going to make sure my main camera has run in edit mode on the pixel so I can actually see where I'm moving this. And I want this text element to be score text. And I'm going to clamp it to the top left. So I'm going to grab this little gimbal here to give it a anchor in the top left. I'm going to hold Alt and click to clamp it. So it's up there. Now, I don't want it to be outside the game view, so I'm going to actually move that down a little bit. Just a little bit. Maybe I should have made I probably shouldn't have the ball bouncing in there. Whatever. You can fix that later. So I'm going to give this no text for now. Or maybe I'll just give it a 0 since it'll start, the score will always start at 0. And that should be good. This will say 0, then 1, then 2. So this is going to show our score. And then next, I'm going to copy this, duplicate it, and I'm going to create another text element called lives text. So this is going to have our current lives. And I'm just going to make the x value negative to move it to the other side. Oh, I have to change the clamp. There we go. Shoot. Let me just undo that. I'll change the clamp to that side, and I'll make this positive. Or I'll just drag it over. Now, notice it is on the left side here. I want my lives to kind of be clamped to the right. So on my Text Mesh Pro component, I'm going to click alignment, and I'm going to click to align it to the left side, like that. So now I have my lives on the left and my score on the right. Perfect. There's my 2 text elements. Now on my ball, I'm going to have to set these. So I need to have, again, a reference to those components in order to change their values. So I'm going to have to create another one here. I'll just do it down here, serialized field, and it's going to be a reference to TMP text. Now it doesn't know what TMP text is because we have to import it using libraries. So TMP, if you don't remember what the library is called, or maybe you remember this, but not the library, I'm just going to right click, go to quick actions and say using TM Pro, and it adds it to the top here. All right, so I want a private TMP text, and I'm going to have a level text, right? Not level text, score text, and lives text. 2 text elements now. When the game starts, I want to set my score to 3, but I don't want to set my score to 3 every time I die. I want to reduce my score every time I die. So I may have to do an awake function for this just to kind of separate the logic. So in awake, I will set my score text, live text, live text.text. So I'm accessing the .text value of this text component, and I'm setting it to 3. Now, I could actually, I need a variable in order to hold the current value of my lives. Like I need to know how many lives I have at all times. So I need 2 floats here, or 2 ints here, sorry. One is a int for score, and one is a int for lives. Now, when the game starts, or when the game awakes, so awake is called before start, just to clarify. So when awake is called, we're going to say lives is equal to 3, and we'll say score is equal, score is always equal to 0 by default, so I can just leave that. I'm setting this to 3. I could also set it here if I wanted. I don't have to set it in awake. And I could say this is equal to lives.toString if I wanted to use the variable and convert it to a string. Do that as well. I'm going to copy this line though. And when I die, when I respawn, I'm going to minus my lives by 1. So I'm using minus minus to reduce my lives by 1. This is the same as if I was saying lives is equal to lives minus 1, I guess. But I'll reduce my lives by 1 when I die, and I will update that in the text. I'll update the text. However, when I reach 0 lives, I want to restart my game. I've failed. I can no longer do this anymore. So I'm going to actually change this a little bit. I'm going to have this happen first. I'll have my sound play first, and then I will reduce the lives. Then I'm going to ask a question. If lives is equal, I'll say less than 0. So if I hit -1, then what I'm going to do is I'm going to use Scene Manager, which again, it doesn't know what that is. So I'm going to right click, go to Quick Actions or Refactorings, and using Unity Engine.Scene Management. And I'm going to say .load scene 0. That's just the default first scene that you have in your game. So it'll reload the scene basically. And I'll just return, which will stop doing everything else after that. So if I reach 0 lives or under 0 lives, I'll restart the game. Else, I'll just continue doing what I was doing before. All right, and the last one is our blocks. So every time I hit a block, I want to increase my score by 1. So I'll say score plus plus to increase it by 1. Lives I was decreasing, score I'm increasing. And then secondly, I'm going to update my text element to show my score. So I'll score text is equal to score dot toString. All right, let's test this out. And then I think I'll be pretty much done here. Oh, remember, when you create variables that require references to things, you have to set those references. I also forgot to add a serialized field for the second lives. So they both need to be serialized. There we go. So I have to pass in the text components into these variables, score text and lives text. So score text goes into score text, lives text goes into lives text, and I'm going to hit play. And here we go. You can see my score is going up. Oh, I lost my, oh geez. Oh no, I'm terrible at this. And I'd lost and it reset. There we go. I may have to increase the speed of my paddle. And notice that no matter how I hit this, oh my geez, no matter how I hit this, it's always going to go in a somewhat angular direction. It's never going to go just back and forth or up and down, straight up and down. That's what that axis thing was doing. If I can hit this at all. I'm absolutely terrible at this game. I apologize. There we go. All right. Let's see. My current move speed, yes. Current velocity, perfect. That is it for time, I guess. So I think I'm gonna make sure I could color code my walls, I guess. That'd be nice. But at least we have a game that works, even though we had that one hiccup earlier. All right. Well, thank you all for sticking around and listening. I'm going to pass it back to Tyler now, if he's okay for that.
Of course. Hello, hello. You can hear me?
I can hear you. Yes.
Perfect. Awesome. Well, thank you. Awesome. Great workshop. I mean, I definitely wouldn't be able to do that, and I probably wouldn't be able to keep up with the game speed at the end there. I was watching you try and beat it. Hilarious. Oh, and actually, you can. I think you can close. I'm going to close this for you. Actually, there we go. Oh, I didn't mean to kick you right out there, Dustin. I just meant to close your share screen. So, but thank you, Dustin. He will be back actually in a minute. I'm going to invite him back in for Q&A, and I'm just going to run through some really quick things here with everybody who's on the call. So let me just share and hope that this doesn't crash my system here, because this is the only thing that ever does it to me. There we go. Okay, so we're just going to go through a few things here really quickly. One of the things I like to share at the end of a workshop is some examples of our students' work. So this is just a few different examples here that you can see on screen, and Vuforia, C# scripting. And then our students in general, obviously, we've taught over 40,000 students, so there's quite a few more than the 6 you see on screen right now. We also do case studies on our website, which provide great examples of what the students completed during the course, after the course, and kind of where they are in XR development or design. But these students here are just some examples, obviously, of some of our great students that we've had come through and kind of what they're doing, where they're working. Some of our courses, just wanted to quickly touch on them. We have a self-paced course that I didn't mention earlier. It is a 6-hour, actually maybe it's 8-hour, I can't remember. It's somewhere between 6 and 8, even though it does say 6 on the screen there. And it's completely self-paced. The whole point is to teach you to develop your first augmented reality application that you can export for your portfolio. Naturally, our longer courses are going to get way more in depth, but this is just a good option for people to self-purchase on the website there. I think that one's a $50 course. Our XR development course with Unity is the 10-week course. The next cohort we have coming up would be May 17th. That's the completely beginner friendly, and it's going to be focused on teaching you coding and Unity fundamentals. The interaction design, April 20th would be the upcoming start date that we have for that one. That course is very similar to the development course. It's 10 weeks, but it doesn't touch on coding or scripting at all. The focus for this one would be entirely on prototyping, user experience, so a little bit different than the development side. And then our boot camp, this is one that we're really, really excited about. Our cohort is coming up really soon. Actually, we've only got a couple more weeks left for people to register for the course, April 11th. And I believe we still have a couple scholarship spots open, which I can touch on in just a minute there as well. But this is a full 6-month boot camp. It dives a lot more in depth, kind of goes a little bit away from augmented and virtual reality development and design when compared to the 10-week courses, and goes a little bit more into a Unity development overall. And you can kind of see what it covers there, parts of it on the screen. But we've got career services, we've got one-on-one coaching, we've got lots of amazing things with that bootcamp. So if you are interested in that, you can reach out to me directly. Basically, any member of the admissions team would be happy to assist and get you on the right track for that. And there is a bit of Unity knowledge required for that one, but we can just kind of go through that with you and see if it would be a right fit. Or we could always default, or usually we default back to our development or design courses if you're a little bit more on the beginner side. So that is the bootcamp. This is on our certification. I like to kind of explain the pathway for people. So we're directly partnered with Unity. We're certified training partners with them. So all 3 levels of certification you can see in the middle of the screen there are going to be provided by us at CircuitStream and backed by Unity. If you do the design course, it would be a designer badge. Development would be a developer certification there, a designer certification, I should have said. And then Unity Developer Bootcamp. We do provide our direct certification, but after that 6-month course, we do also include the exam cost through the Unity website directly. If you'd like to go a step further and go through to do their associate level certification. Both come with networks. I mean, we have a huge internal network. Unity has a big network. We're partnered, but both are beneficial. So, if you have the opportunity to access both, then that's why we would include it in the boot camp there. And then community support. We have a lot of amazing support here internally. Lucy and Archie take really good care of us, but we have events, we have coffee hours, show and tell, demo days, game jams, local meetups, just lots of stuff that's going on. And then our Slack community obviously is going to be the internal network that people would communicate with during and after the course. The development and design courses I mentioned, they are beginner friendly. So the cool thing with that is really there is no experience required. Beginners don't have to have any fear for those. I also just want to clarify again for the bootcamp specific, that one does have a little bit of experience required, but so this would be more for the 10-week courses. Then the price points for our 10-week courses, the starter package is $3,950. The plus package is $4,950. The difference between the two is that the plus package would come with an additional 4 weeks of C# coding and scripting. Works really well with the development course. It works with both, I guess, if you're a designer looking to learn the coding side as well, but definitely with the development course. And the plus package also comes with 10 additional hours of one-on-one time with the instructor to kind of go through, any sort of project ideas that you have. You can kind of jump off the course curriculum script a little bit and focus on some things there. So that's the pricing for the 2 main bundles that we have. For the boot camp, our 6-month boot camp is $14,995 at the full price. We do offer scholarships. We've had 15 seats available for this first one. And I don't know, I think we still have 1 or 2 of the scholarship seats available, and the boot camp overall itself is starting to fill up quite a bit. So yeah, if you have any questions or interest in that, just reach out to myself. Any member of the admissions team can help you with that for sure. And then this is really important with that as well. We do offer finance plans. This would be for all 3 of the courses mentioned there, development design and the boot camp. The boot camp itself, climb is going to be for the American students specifically. That's our American finance partner, and they extend loans for up to 5 years. And you can do it individually, or if you're not eligible, you can do it with a co-borrower as well. And then for anybody outside of the US, so if you're Canada, overseas, basically anywhere else, we do offer internal finance plans directly through CircuitStream, and they would range between 3 and 12 months. So 3 months to a year there. And then the admissions team, you probably recognize the guy in the top left corner, or maybe not, because I look a little more polished in that photo, I guess, but I don't have a haircut. But that's me, Tyler Trapp. We've got Leanne, Roham, Shoshana, Stella, Brendan, and Marvell. Great team. We're kind of scattered all over the place. We come from all different backgrounds, so we can kind of assist you getting you going in any of the courses, or if you have any questions there. This is just some links here. This entire presentation, it will be sent out and shared with everybody who's participating. But these links here, if you want to take a screenshot, this would be some of the links directly to our courses. We do partner with universities for some of our courses, not so much for the bootcamp quite yet. But the links there would allow you access to the other courses. And then for anything, including the bootcamp, you can go right to the bottom link there, the circuitstream.com/learning, or you can just reach out to us here directly. And that's it. I try and get through this part as quickly as I can at the end, so you get all the information, the valuable details that you need, but you don't feel like you're stuck with me here going through everything. So without further ado, I'm going to exit out of this, and we are going to go back to the presentation here. Perfect. And I'm just going to close this guy here. And Dustin, if you were there, you are welcome to pop back up in here now. I'm just going to go over to the chat and the questions side.
Yeah, most of the questions are already answered. I do have one here that's actually a good question. Why don't we scale ball movement to time.delta time, just like we do with paddle movement? This is this is actually a really great question, because we don't need time.delta time in this case. We really don't. I could remove that, and it'll work perfectly fine. The reason, though, is because we are setting the velocity of the rigid body. So when we move something in Unity, we give it a vector 3 as a position to move to. However, a rigid body handles that for us. So when we tell it to move at this velocity, it handles that movement itself. So it already scales itself by time.delta time. So whenever we're setting the velocity, we don't have to really do that. So if we were rotating it or moving, like setting the position like we were before, we would scale it by time.delta time. Absolutely. But in this case, we don't have to. That was a mistake on my end.
Perfect. Okay, I'm going to put that one down. And then you said you'd answered a few. I'm just going to mention them really quickly here. Is the script a specific language? C# coding and programming language is what we would be using. The link to rewatch later, yes. And you got the link for the Unity install there. So that's good. I'm going to pop back over to the chat side here and see if there's anything else that's kind of come up. Dustin, do you see anything else there? I think we hit them all.
Yeah.
Yeah, I think we're good. And like I said, for everyone, the full recording of this is going to come out. If you have any questions that we didn't get to today, or if you do think of something after the presentation, you can just email us at the team here. My email is Tyler, Tyler, at circuitstream.com. Shameless plug in the middle of the presentation here, but cool. Well, I think that's it. Dayon is typing. Dayon, do you have any more questions for us? He's put my email up on the side there. Awesome. So yeah, that's it for today, folks. Thanks for joining us. We do run these pretty much every week, so feel free to register and join us for the next one that we'll have coming up here. And I guess I can end it. Oh, we're not too bad. We're about 10 minutes early today. Oh, I guess not. Actually, we had planned it to go to 2:45, so we're a couple minutes late, which is good. Awesome. All right. Well, thank you so much, everyone. I will leave it there. Thanks for joining, and have a great day.
Thank you, everybody.